Hello and welcome to episode 3 of AstroMagnet. I'm Arush Ramadurai,
And I'm Ishan Chakravarti.
and today we're talking to Anna Sajina, Associate Professor of Astronomy and Astrophysics at Tufts University.
Welcome to the podcast, Professor Sajina.
Thanks for having me.
So when did you first get interested in astronomy? Why are you interested in astronomy?
Well, I always liked science, so I always knew I wanted to do something in the STEM fields when I started college. And actually, I started off in an engineering program, and then I decided I like more the physics classes in that program, so I switched to physics in my second year. And then I just took an astronomy class just as an elective in my kind of sophomore year in college, and I really liked it. And I ended up getting a degree in physics and astronomy, like a double major. And then I continued on with that. So it wasn't, a lot of my colleagues know they want to be astronomers when they're like 5 years old and grow up with it. But for me, I actually came to it in college. But I always knew it would be something science, yes. Oh, and just to answer your second question, which was why am I interested? Well, I think astronomy has this very, very profoundly interesting aspect to me, which is that it takes you, it forces you to think on kind of time and space scales that are very, very different from our everyday experience. So you really get to think about things that take place over billions of years and over like vast, vast scales. And it's sort of, I think it's kind of interesting for humans to contemplate that, even for those who do not professionally study astronomy. So even just when you take an astronomy class, that's what, when I teach, I try to convey that to the students, that just spend a little bit of time to think about our place in the universe and the universe at large. It's kind of a very good thing, I think, for people. I think if we spend more time thinking about that, we would kind of all realize how we are all basically the same and we all share this tiny little fragile world that exists in this vast universe, and all our kind of differences and things kind of really fade away in a way.
So did you have any particular courses or research experiences you enjoyed?
Yes, I actually, that's a great question, because like I said, taking a class with a very inspirational professor helped me really get into astronomy, which I hadn't seriously considered beforehand. And so I ended up deciding to do a double major. But I still wasn't really thinking of it as a career until after my junior year. I went and did an undergrad research experience for the summer. And so I actually worked on a project which gave me a kind of a hands-on experience of what it's like to actually be doing research and what doing astronomy would actually look like. And I thought I enjoyed that tremendously. And so after that, I started thinking, oh, I should try to go to grad school. So even now, I try to give as much research experience to our current undergrads as possible, just because I think that's a whole other thing compared to academic classes. But just from the perspective of high school students, what do you need? What do you need is it's a science. You need math. You need physics. We actually also use a lot of we do a lot of computing. So computer science is actually quite useful as well, because there's a lot of programming involved. Data analysis. So nowadays in modern astronomy, it wasn't so much the case when I started, but in modern astronomy, there's a lot of data science and machine learning and all these things going on. So all these things are quite useful. Sort of slightly less expected, chemistry comes in handy on occasion, because I've done some work at various stages with spectroscopy, like infrared spectroscopy of various objects in space, and understanding what kind of chemical compounds and such produce the features that we see in this spectra is kind of useful.
So did you do a postgraduate degree, and Can you talk a little bit about your experience with that if you did?
Yes, okay, so I basically, so I did an undergrad physics and astronomy kind of double major thing. And then I went on to grad school. So this was in Canada. I actually lived in Canada at the time. And so I did a PhD in Canada. And then after that, I moved to the States for a postdoctoral kind of fellowship. And so I worked as a postdoc for a bit, and then I got my faculty position at Tufts University in 2010. So I've been here now 11 years. Yeah. So that's a pretty standard career track, actually. I did a couple of postdocs of 2 years each or so. So roughly speaking, that's kind of what it looks like. So it takes a lot of, obviously it's quite a few years of education. I think, so 4 years of undergrad, and I did 5 years for my PhD. Some people take a lot longer, but I think 5 to 6 years is normal. And then I guess 3 to 4 years of postdoc, and then you basically start applying for permanent jobs. So this is the typical career track. And so obviously you have to also be open to traveling, because those job involves traveling.
So what research teams do you work with and what do they study?
So yes, nowadays astronomy is quite collaborative. So so myself and more broadly the group at Tufts is involved in some large collaborations, which is great because it gives us access to really state-of-the-art facilities and data. I also continue to enjoy smaller so those collaborations of hundreds of people basically. But I also still really enjoy smaller collaborations with like 3 to 4 people, where we work on some smaller projects, because those are kind of more, it's nice, it's like a smaller group. And so it's relatively rare, especially for observational astronomers, it's relatively rare to be working on a project alone. You normally do it in groups. And at the very least, I do things with students. So now that I'm faculty, I work a lot with my students, both undergraduate and graduate students, and typically with also some external collaborators from my collaborations outside of Tufts.
So what is your main area of study right now? So what kinds of questions does your research aim to answer?
So I work broadly on questions of galaxy formation and evolution, really everything that has to do with how galaxies formed and evolved after the Big Bang, and how we got to the universe that we see today, like the present day universe. So this is very broad, but there's lots of questions inside of that. But yes, I generally study galaxies.
Can you talk about what some of those questions are right now, like what we don't really know and what is important for us to know?
So one specific, so there are a few interesting questions. One is, so we've come to realize that essentially every massive galaxy has a supermassive black hole in its center. Exactly how that supermassive black hole is influenced by, and in turn influences the evolution of the galaxy that it's located inside, is still unclear. There is evidence that the growth of the galaxy and the growth of the black hole are kind of correlated. We say that they co-evolve, but exactly how, exactly which processes dominate is still very unclear. And so these are some of the things that I look at, trying to kind of understand exactly how these things are related. The other thing is that we sort of tend to think of galaxies as kind of these isolated islands in the void. Like you think of this Hubble Space Telescope images and you see a bunch of galaxies inside nothingness essentially. But that's actually the wrong way to look at it, because if you look at these simulations of dark matter, or if you look at like where there's just gas, you can see that rather than being just islands in the void, they're all interconnected in a kind of a web. So there's this kind of thing that we call the cosmic web that really looks like a web. It has like these filaments and knots and things, and so all of the galaxies are really just part of that. They're just like the little bits of that web. The rest of it we just don't see because don't really have stars, and we see the universe through essentially starlight. And so we only see, I mean, another analogy is if you think of the ocean, and if you think of an archipelago of islands, you see just the islands and you think they're separate, but if you actually see under the surface, you see how they're all kind of just the peaks of vast mountain ranges, and they're all really connected. And so that's kind of like a fairer way to think of galaxies, is that they're just like the little peaks of the cosmic web. And how a particular galaxy's location within that cosmic web affects its formation and evolution over time is one of the questions that people are very interested in at the moment, trying to figure out how the environment of the galaxy might be influencing the galaxy itself. Because again, they're not really isolated, they are actually interconnected in this way.
So what sorts of astronomical or astrophysical phenomena do you study in these galaxies, or like between these galaxies?
Well, like I said, I look a lot at like the supermassive black holes, like I said before, and I look at the properties of the host galaxies and the properties of the black holes and how they might be related. And I also look at the other question that I mentioned, which is look at how the properties of galaxies might be related to the kind of environment they live in. So, like in the simplest thing, is it like the very denser environment or the kind of like much sparser environment, and figure out if their properties are actually correlated with that. So again, a human analogy might be, how is your growth and development as a human affected by the fact that you grow up in the suburbs versus in the city core? So think of it that way.
So why in the end is it important for us to study galaxies? What greater ramifications do they have for what we know about the universe and astronomy?
Oh, it's a great question. I'd love to answer this question actually, because people very often don't think about it, but galaxies are the nurseries of all stars. So without galaxies, you would not have stars, and all star formation, as we now understand it, is also associated with making planetary systems around it. We think that basically all stars have planets around them. And so all the processes that go into forming galaxies, how galaxies form and evolve, are really directly tied to stars and star formation and planet formation and so on. And so those things are all related. In an essence, we wouldn't be here talking about this if we didn't live in a galaxy, and if all the processes in that galaxy didn't allow us to be here to talk about this. So I think it's part of kind of why are we here, kind of a big picture question.
So could you talk about some of the techniques and instruments you use to study galaxies?
So we start with observations, and some of our observations are taken with telescopes on the ground. Like we use a lot of data currently at Tufts. We use data from, say, the Subaru telescope in Mauna Kea. And we also use a lot of data from telescopes in space, including currently we're using data from the Spitzer Space Telescope. And we are also very much looking forward to the new James Webb Space Telescope, which is in a way a successor to both the Hubble Space Telescope and the Spitzer Space Telescope. And the astronomy group at Tufts has active programs kind of lined up for the James Webb Telescope when it launches. And so it starts with data, and like any physical science, you basically try to make sense of the data. The way we make sense of the data is through both analysis of the data, where a lot of the techniques, like I mentioned earlier, start to involve some more sophisticated data analysis techniques like machine learning methods, and also comparison with theory. And a lot of the theory really comes from computer simulations of galaxy formation and evolution. Then you compare the simulated universe in a way with the real universe, because a lot of the processes we're talking about take place over billions of years. Like a galaxy is actually a very dynamic thing, but it's a very dynamic thing on very, very, very large time scales. And so we can't really observe this process in real time. And so how we do this is we basically run simulations where we put in all the physics that we think is going on. And then we essentially look at how the galaxies that you make in the simulation, how this kind of simulated universe in a way compares with the real one. And so you literally compare properties, compare things like distribution of sizes, masses, environments, growing supermassive black holes, any property you want, you basically compare the simulation with the real thing and you try to see if they match or not. And because in the simulations you put in the physical process that you think are going on, if things don't match, you can add new processes or tweak the parameters and figure out like where things might need some adjustment. Does it make sense?
Yes, yes. So we also wanted to ask you about kind of your career in general. So have you experienced any challenges in your career? And if so, how have you navigated them?
Well, like I said earlier, my career, I think, is fairly kind of standard in the sense of undergrad, grad school, a couple of postdocs, faculty. I know a lot of people who have, I mean, people think that that's the only career path, but I actually know a lot of people who have taken other paths and sometimes have gone off into industry, sometimes have taken a break and then come back to school. And then, and like, there's no single answer really. Mine is kind of the very run-of-the-mill standard variety as far as kind of like the progression of things, right? One challenge is, like I said, because those astronomy jobs are not, there's not like hundreds of them in one city. They tend to be few and far between. You have to basically be willing to travel. And so it takes a long time of kind of like a few years in this place, a few years in this place, a few years in this place. In my case, one of the challenges, which is actually also extremely common in our field, is that my husband is also an academic. And since he's a couple of years older than me, he already had a faculty job when I was still a postdoc. And so we had this kind of two-body problem a little bit. And so that was the major career challenge. And actually at that stage, I know people sometimes basically give up and look for other jobs. But we were lucky enough that we both ended up here in Boston, and so we're good.
So if these astronomy jobs are, as you say, few and far between, does that mean that the astronomy job market is relative to maybe other professions very competitive? Is it difficult then to get a job in astronomy?
It is on the competitive side, yes. So I would say it gets more competitive the further along you get. So so getting a PhD, if you're a reasonably good student, is not that hard. I mean, you have to have like you have to be a good student. So there is like I said, there's certain level of skills that are required, like any STEM field, like data handling skills, math, physics skills, things like that. And the astronomy PhD, I don't know exactly, I actually should look this up, but I don't know exactly what fraction of astronomy PhDs actually continue, because there is already a fair number that afterwards go on to industry. And that's fine. This PhD prepares you for a lot of other jobs. I've actually had students in the past who chose to go to work as data analysts, for example. And so, especially because of all this work we do with data handling and machine learning and things like that, in fact, it's a fairly easy transition for people to become analysts, which is pretty good. Those are good jobs and pay quite well. So people sometimes go into, well, in fact, I also know people who go into teaching, like high school teaching, both in public schools and in private schools. So because sometimes people go and do this for a while and then they realize that the teaching aspects of it are more interesting to them than the research aspects of this. And therefore they do let's say they do a PhD and then they go on to a teaching job. Or like I said, they go into industry and do something with their kind of technical data handling skills. So after that, postdocs, those who want to continue in academia tend to get postdocs. Those are still not too bad, considering that there is some attrition at the PhD level already anyway. Getting faculty jobs can get hard. I mean, that's true, to be honest, of almost any STEM field. Faculty jobs are not easy. But for people who are persistent and are good at their job, you can get it. Yeah. But yes, those things don't just hand them out. That's for sure. Yeah. But one thing just I want to say about this, I think the study of a lot of sciences, not just astronomy, but the study of sciences, even going on to grad school, is a worthwhile thing, even if you don't end up as faculty, because it still opens a lot of career options. The majority of our physics and astronomy majors at the undergraduate level do not pursue an academic career, and they still do very, very well professionally.
So you mentioned before that it's important to have a good math and physics background for a career in your field, but do you have any other advice?
Let's see. Besides the actual kind of technical skills, working in science requires kind of like a natural curiosity. So just be what you guys are obviously doing right here, right? Just be interested and read a lot about things and think about things and just be interested in, finding out more about the universe. So just being good at math is not enough in a way.
Is it all right if interested high school students contacted you for advice and guidance via email?
Sure, yes. Yes, I'd be happy to talk to people when needed. Both in general, but also in particular if people are interested in applying to Tufts. So I can tell you about the astronomy program and the physics and astronomy department here at Tufts.
Okay, thanks for your insights. So that was Anna Sajina, and to learn more about her field, check out our website for additional resources.
Thank you for listening, and thank you, Professor Sajina, for visiting us, and we'll be back soon with another episode.
Thank you, guys.
Thank
Bye.
you.